Welcome back. We're going to continue our forensic analysis of a network capture through Wireshark. This time I decided to use my Mac directly instead of virtual machines because commands seem to work much better than in Kali Linux. I'm actually able to have output from some commands unlike Kali. And here I have a sort of cheat sheet, a list of commands I want to show you. I'm sorry about it, but comments are in Italian, so probably some of you are not able to understand them. We're going to use the same capture file as before, but we'll be delving much more into our analysis. Let's start seeing how many encrypted beacon frames we can find in our network capture. And we're going to use TCP dump for this. So this is the command we want to use. In this command, this value WLAN 0 and so on represents the beacon frame type. Here we have the number of encrypted beacon frames. Of course, we don't have to scroll each one individually to find what we're looking for, but we can simply pipe the grep command to the previous command, and we're gonna have the frames related to this long gunman access point like this. You see that we have only one frame referred to our rogue access point. Exactly this one. And you notice that it broadcasts on channel 6 and the privacy bit is enabled. Okay, now we want to see how many stations successfully associated with this rogue access point. And for this reason, we're going to use TCP dump again. Now, I'm going to explain a little more in detail the parameter of this command within my post. I only remark here that WLAN 0 times 80 stands for the beacon frames. We saw that in our previous command. Okay, so I'm ready to run the command right now, and with rather luck, I had this problem in the previous video, and it seems me to remember even back in the day when I performed the lab for my class, because there's a problem with the capture file. It seems to be truncated somehow, so let's start to the next command, which will tell us the number of nearby stations, and this time we're going to use T-Shark for this. Now the WLAN.fc.type underscore subtype 020 represents data management frame, while the protected field equals to 1 indicates encryption. Now only the MAC address of the wireless access point is necessary to get this command to work. So I'm ready to launch it. And I actually screwed up something here. Anyway, I was able to make it work, and we can see we have 66 stations successfully connected to our wireless access point which means 66 frames were exchanged between the rogue wireless access point and other devices on the network. We can build on this command and narrow down these frames, and we can see that 51 frames were originated by the rogue access point and 15 frames were originated by another device. Now 51 out of 66 is approximately the 77% of our traffic. So the rogue wireless access point originated 77% of our traffic. We can actually look up the MAC address of the other device as well. And we see we can find the brand thanks to the first part of its MAC address. We can build more on the previous command that have the frames per destination address, simply replacing the SA in the previous command with DA in this new command here with T-Shark. And we see that 59 frames were intended for the MAC broadcast address, which appears to be kinda abnormal. That shouldn't be going on. We can build on the previous command and see both source address and destination address for all the frames exchanged in our network. I only need to add this parameter in the previous command. And here we see something interesting. We see that 50 frames were exchanged between the rogue wireless access point and the broadcast MAC address, and 9 frames were exchanged from the previous station we saw before and the MAC address. Now 50 out of 66 corresponds pretty much to 75% of our traffic. So there's definitely something going on in this network. We see that the other station exchanging frames with a broadcast address is the one we looked up before. And it exchanged 9 frames, which corresponds to approximately 13% of our traffic. And the remaining frames were exchanged between other devices. So there's definitely something going on in this network, and we need to delve further to understand what the problem is here. And I'm gonna actually explain you what my conclusions are at the end of this video. Now we want to understand what's the number of aggregated frames transmitted by each MAC address through this new command in T-Shark. This parameter WLAN FC type equals 2 represents all the data frames. Okay, so this confirms that 59 frames were transmitted to broadcast MAC address. Once more. Like I said, this is something that shouldn't be going on. A plausible reason for it to occur could be an ARP request from clients. However, the number of such requests appears to be abnormally high compared with other stations, and a more plausible explanation for such a behavior could be an attack on the wireless network. In fact, if we see the number of frames containing association requests, we see an abnormally high number. You see a bunch of frames here. So there's a huge number of association requests intended for these stations here on the network. If we compare that to the number of association responses, change this parameter here type to 1, we see that only one association response was transmitted. So once again, this is something abnormal that's going on. In fact, what seems to be going on is primarily an attack to the wireless network using ARP requests. Replaying ARP requests is a way to speed up WEP cracking attacks. I was able to successfully crack the WEP password as I showed you in the previous video. So we were able to delve much more into our traffic capture with Wireshark, T-Shark, and TCP dump. Actually, T-Shark maybe allows a little more flexibility than Wireshark. Wireshark can also be used for hacking and pen testing other than for forensic purposes, but we'll maybe analyze it in another post. I'm running out of time here. It's a tool that can be used anyway for good or bad, depending on who uses it. So that's all for today, guys. Have a good one and keep following me. Bye bye.